Delighted to have you on the stage, Francesca. So she'll be telling us about fully printed additive manufacturing indoor PVs.
Yeah,
So when you're ready, Francesca,
yeah, thank you.
the stage is yours.
Thank you, Kasia, for introduction. And good evening to everyone. I am Francesca, and today in this presentation, I'll try to share some insights, hopefully interesting insights, on the fully printed additive manufacturing process that Ribestech developed for the fabrication of its indoor photovoltaic modules. I'll also be outlining how this process could evolve in future scale-up phases, thus providing you some perspectives on the future of our technology. And first of all, I'd like to give you a bit of context and background of Ribestech. Our story starts about 10 years ago in the printed electronics labs of the IIT, the Italian Institute of Technology in Milan, when Ameta Sarel, leading company in printing machine and our main investor to date, started a collaboration and joint lab for the development of innovative printable technologies. In 2016, it was officially funded as a startup, still incubated in the IIT with the mission to produce organic photovoltaic modules. And in 2019, we finally got our own facilities and moved to our current offices and labs, where in 2020 we installed the roll-to-roll printing line to develop our process and move on to the production and commercialization phase of light harvesters to power indoor wireless devices, which is where we are now. And I'd say that since the startup foundation, we identified a great potential in providing power to IoT devices. The Internet of Things has been playing and will play even more in the future a pivotal role in helping to effectively address the challenges that we have to face as a society in a world that is getting more and more digitalized as well as more and more populated, starting from cutting down carbon emissions to counteract climate change. To improving workflows productivity, and generally there's the necessity to make things more efficient overall and be more mindful of the way that we consume the resources. All these challenges rely on making data-driven decisions, and that's where IoT comes into play. To make things quantifiable and measurable are needed billions, if not trillions, which is the direction in which we're going, of distributed wireless devices and sensors connected to a network. And currently, one of the main obstacles to overcome for efficient IoT deployment is the dependency from standard batteries to power IoT nodes. Batteries are reliability for multiple reasons that span from economic considerations for business sustainability, related to maintenance costs for battery replacement and recharge in billions of nodes, which of course is not sustainable, to environmental concerns, as batteries generally contain either toxic or polluting elements, which are extracted with unsustainable mining practices. And last but not least, at some point, governments and institutions will inevitably start to impose regulation towards banning or at least heavily limiting sustainable energy sources. And this is where our light harvesters comes into play. Scavenging energy from the environment is the most efficient and sustainable way to power the Internet of Trillions. And we do so with organic photovoltaics, which we see as very well suited to be integrated in wireless devices and everyday items. OPV modules are flexible and ultra thin, which makes easy to seamlessly integrate them into various devices without completely overturning the design of the object that needs to be powered. It is inherently an environmentally friendly technology with a low carbon footprint thanks to the low temperature production processes and due to the origin of the materials used. And it is also recycling compatible as most of the stack is PET. And finally, it is a relatively efficient technology, also in indoor environments, which is the most critical environment as there is less energy available from the light sources to start with, and thus it is crucial to maximize the amount of energy harvested and delivered to the electronics. And coming to Ribestech OPV devices in particular, we always strive to keep a process as simple and as flexible and adaptable as possible. Therefore, we chose to stick to a fully additive manufacturing, meaning that every layer of the PV cell, here you can see a generic sketch of an inverted organic cell and all the layers that compose it. As I was saying, every layer of the PV cell is printed through standard roll-to-roll printing techniques directly on the substrate of choice, and each layer is patterned directly at the deposition stage, meaning that we can minimize the number of production steps needed. There's no additional patterning